So let us discuss some examples of aldehydes and ketones. In case of aldehyde functional group, the suffix is al. In case of a ketone functional group, the suffix is on. Of course, in case of aldehyde, there is a special suffix, that is carbaldehyde. Whenever it is needed, we will definitely use that. So let us move on to the first example. Here it is an aldehyde functional group. Only one carbon atom is present. Root word is meth, ane, al, methanol. And here there are two carbon atoms. Therefore, the root word is eth, ane, al, ethanol. It is a chain terminating functional group. Therefore, need not to indicate the position of that aldehyde, because it is always at a first position. And here this is the first carbon, second carbon, and this is the third carbon. This is branch, therefore we have to use a prefix. So that is 2-bromo. Root word is prop. Single bonds, all CC bonds are single bonds. Suffix is al. So 2-bromo propanol. So this is the first carbon, second carbon, third carbon, and fourth carbon. So here this is a prefix. So that is at a third position. So that is 3-chloro. Root word is but. Carbon carbon bonds are single bonds. Aldehyde functional group 3-chlorobutanol. So this is the first carbon, this is second carbon, this is the third. You can move left side or down side, whatever it may be. The result is the same. Now this is branch, and here it is 3-methyl. 3-methyl, 4 carbon atoms. Root word is but. 4 carbon atoms in the long chain. Carbon carbon bonds are single bonds, and it is aldehyde. So butanol. And most importantly, there are two aldehyde functional groups. So both of them will be in the long chain. So this is the first carbon, this is second carbon, third, fourth, fifth, and sixth. There is no substituent. Therefore, straight away root word hex. All carbon carbon bonds are single bonds. Ane. Now we are indicating the positions of aldehydes 1, 6 diol. So two aldehydes are present. They are at 1 and 6 positions. So this is 1, 6 diol. You have to notice here I didn't drop E in this example. And most importantly, chain terminating functional group is directly attached to the ring system. This carbon cannot be included in the longest chain. Therefore, of course, this is the first carbon. It is a cyclic, so it is a cyclohexane. First carbon of that cyclohexane, there is aldehyde, but that carbon could not be taken into the longest chain. Therefore, we are using special suffix, that is carbaldehyde. Same thing, this is benzene aldehyde, benzene carbaldehyde. Common name, earlier common name was benzaldehyde, but IUPAC accepted that benzaldehyde. So benzaldehyde is not only common name, it is also IUPAC name. So here, according to the rules, if you give, this is benzene carbaldehyde. Benzene carbaldehyde. So this is first carbon, second carbon, third carbon, fourth carbon. Here this is a second grade functional group. OH group is indicated by using prefix. The prefix name is hydroxy. Therefore, it is a 3-hydroxy butane all, butanol. And here, most importantly, in this example, we have two functional groups. One is ester, another one is aldehyde. According to IUPAC sequence rule, ester gets more priority. Therefore, this is the first one, this is second one, this is third one, this is fourth one, and this carbon is the fifth carbon. Observe carefully. Now, this aldehyde is indicated by using prefix. Whenever aldehyde is present as a substituent or second grade functional group, we use two different prefixes. One is pharmyl, another one is oxo. So formyl we have to use if that carbon is not coming into the longest chain. If this carbon is not coming into the longest chain, then this formyl, this indicates a formyl. But in this example, this carbon can be included in the longest chain. Therefore, instead of a formyl, in this example, we have to say oxo. But most importantly, while naming esters, alkyl group attached to oxygen should be indicated first. Therefore, it is methyl, then it is oxo, 5-oxo. Root word is pent, ane. Don't forget, ester is the first grade functional group, O8. And here, again, if you see ester functional group and aldehyde both are present, but ester receives more priority 1, 2, 3, 4, and 5. And this is the longest chain. You just think why this is longest chain, why not other possibilities? You have to apply the rules. This is ethyl group, this is methyl group, and this is oxo. But irrespective of alphabetical order, alkyl group attached to oxygen should be indicated first. Therefore, ethyl. Now this branch is methyl. This is oxo. So according to alphabetical order, methyl comes first. Ethyl, 4-methyl, oxo, that is at a fifth place, 5-oxo. Root word is pent. All carbon carbon bonds are single bonds, and it is ester functional group. So pentane O8, pentanoate. So here this is the first carbon, second carbon, third carbon, fourth carbon, and fifth carbon. There is no prefix, there is no substituent. It is a primary suffix. Here it is a secondary suffix. Straight away root word, that is pent, 3-ene, 3-ene, 1-all. Otherwise, you can also write 3-ene-all because it is a chain terminating functional group. In this situation, E should be dropped, and these are some examples of aldehyde. Now let us take some examples of ketones. So this is first carbon, second carbon, third carbon. No prefix, root word, primary suffix, secondary suffix. In case of ketone with 3 carbons, need not to indicate the position because that is understood. Only possibility, that is at second place. Even if you want to write in that situation, we can write a propane 2-one. In that situation, you have to write E here. Next example, longest chain. Numbering should be from left side. Totally there are 6 carbon atoms. The root word is hex, ane, 3-one. Because ketone is not chain terminating functional group, we need to indicate the position. So here this is the longest chain, 1, 2, 3, 4, 5, 6, and 7. This is the branch, that is methyl, 6-methyl, hept, ane, 2-one. So here there are no branches. This is the first carbon, cyclohexane, 1-one. You can start numbering either from left side or from right side. Ketones are receiving the same position. No prefix, pent, ane, 2, 4, dione. First carbon, second, third, fourth, even from right side you can give. Butane, 2, 3, dione. Ketone and CC double bond, ketone receives more priority. Therefore, numbering is from right side. No branch. Hex, 4-ene, 2-one. And most importantly, here whenever benzene ring is attached to ketone group directly, this cannot be taken into the longest chain. Therefore, this is named as phenyl. So, this is first carbon, this is a second carbon. At the first position, there is a phenyl group. Therefore, it is one phenyl. Root word is eth, ane, one, ethanone. Again, we have a phenyl ring attached to ketone group. So, this is first carbon, second carbon, third carbon, fourth. And this is a phenyl group. So, this is one phenyl, but, ane, one one, butanone. And in this situation, there are two phenyl rings. Therefore, this is only the longest chain. Hence, the name is diphenyl. Root word is meth, methanone, diphenyl methanone. And here we have aldehyde and ketone. Aldehyde gets more priority. So this is 1, 2, 3, 4, 5. Now ketone is second grade functional group. In order to indicate the name of second grade functional group, we have secondary prefix. When ketone is present as a prefix or substituent or second grade functional group, we have to say oxo. Therefore, it is a 4-oxo pentanol, because aldehyde is chain terminating. By default, that is at first place. And here we have ester and ketone. Ester gets more priority. This is first carbon, this is second carbon, this is third, and this is fourth. Its name is oxo. Its name is methyl. While naming esters, always alkyl group attached to oxygen. Ester oxygen should be indicated. So this is methyl 3-oxo, root word butane O8, butanoate. Ester is the first grade functional group. You have amide and ketone. Again, amide receives more priority. First carbon, second carbon, third, fourth, fifth, and sixth. It is a 5-oxo hexanamide. Hexanamide. And here we have ketone functional group. 1, 2, 3, 4, fourth position. 1, 2, 3, fourth position. From both the sides, first grade from both the sides, the functional group is getting same priority. Therefore, I am considering this branch. Like this, numbering will be given. And here this is methyl group located at second place. 2-methyl heptane 4-one. Ketone is at the fourth place. Again, we have aldehyde here. 1, 2, 3, 4, 5. So this is a 3-methyl pentanol. 3-methyl pentanol. So if you start numbering from right side in the next example, 1, 2, 3, 4. 1, 2, 3, 4. However, ketone is getting same priority from both the sides. So here any side you can give, any side you can start. So this is no prefix, heptane 4-one. Now this is aldehyde functional group 1, 2, 3, 4. Now this is substituent located at the fourth place. This is a 4-phenyl butanol. Now you have ketone and alcohol. Ketone gets more priority. Alcohol will be second grade functional group. Totally there are 7 carbon atoms. At the sixth place there is OH group. Prefix name of OH group is hydroxy. 6-hydroxy heptane 3-one. Again aldehyde here 1, 2. This is branch at the second place. So 2-phenyl ethanol. Next, aldehyde. Chlorine is a substituent present at a fifth place. Prefix is chloro, 5-chloro, pentanol. So here aldehyde functional group 1, 2, 3, 4. In any direction you can move because length of carbon chain will be same. So this is at fourth place you have ethyl group. So this is a 4 ethyl hex ane all hexanol. So these are examples of aldehydes and ketones.